Hi everyone, in this video we're going to go over the synthesis of aspirin lab, part A. So in this reaction, we're going to react salicylic acid with acetic anhydride to give us acetyl salicylic acid, also known as aspirin. This will also form a byproduct called acetic acid. So in this reaction, aspirin is an ester. And previously we've discussed that to make an ester, you could combine an alcohol with an acid anhydride. There are other ways to make esters as well, but in this case we want to specifically make aspirin. So in this reaction, the first part of the acetic anhydride molecule is going to create a new bond with the alcohol on salicylic acid. And then the other part of the acetic anhydride molecule will create a bond with the hydrogen from the alcohol on salicylic acid. So we end up with two products. Our ester, which is aspirin, and our byproduct, acetic acid. So in the procedure, what we're going to do is weigh about 0.25 grams of salicylic acid, and that it will be a solid, so then we'll place that into an Erlenmeyer flask. Your procedure says to use a test tube, but we're going to use an Erlenmeyer flask in the video. Then you're going to add 15 drops of acetic anhydride. So that will also go into the Erlenmeyer flask. And last but not least, we need to add an acid catalyst. So your procedure says to add 2 drops of concentrated sulfuric acid. In the lab video, you'll notice that we're using a different acid, phosphoric acid. And they'll do the same thing, but as long as it's a strong acid, that's the important part. So we'll add some drops of phosphoric acid as well. Now, once everything is in the Erlenmeyer flask, we need to make sure that it reacts. So we're going to add some heat by placing this in a hot water bath. After about 15 minutes, everything should have reacted and dissolved in the Erlenmeyer flask. So we'll remove it from the heat, and then we want to try to initiate crystallization of the aspirin. So we're going to add some cold water to the mixture in the Erlenmeyer flask to try to initiate crystallization. We'll also place the Erlenmeyer flask in a cold water bath or ice bath to ensure crystallization of aspirin. So once we feel that crystallization is done, then we need to separate the crystals from any leftover liquid. So we're going to use a procedure called vacuum filtration. So this is a method similar to making coffee. So if you've ever used a coffee maker, you have your solid beans that you put in some filter paper on the top, and then you run water through it, and liquid goes through the filter paper into the flask below. So this is kind of a similar idea. Now in this case, we're going to use something called a Buchner funnel with some filter paper in the bottom. And there's also holes underneath that allows liquid to drip through to this Erlenmeyer flask below, or also called a filter flask. Now, this filter flask is connected through rubber hosing to something called a trap bottle, and then that is further connected to something called a vacuum line. So what we're essentially doing is creating a vacuum. So we're kind of sucking through air, and that's going to pull liquid down into this Erlenmeyer flask or filter flask and leave any solid up above. So once we're done creating our crystals in our Erlenmeyer flask, we'll just pour that into this Buchner funnel, we'll collect the solid on top, and any leftover liquid will fall through or be sucked down into the filter flask. So here's a better picture of a Buchner funnel. And then this is the filter paper that will fit right inside the Buchner funnel. So we'll just place that here, and that will cover up these holes so that only liquid can go through, but solid will stay on top. So then, once we've separated out our solid, we'll let it dry, and then we'll remove it from the Buchner funnel and weigh it, and we'll see how much aspirin we created. So once we have the mass of the aspirin, we're also going to do a calculation to see how much aspirin we actually formed in the experiment. So that's where this calculation comes in, the percent yield. Now you might remember this from previous chemistry courses, but it might also have been a while since you've done this calculation, so I wanted to go over it with you. Okay, so let's say that we initially started with 0.25 grams exactly of salicylic acid. And then let's say our actual yield, the amount that we actually produced of the aspirin in lab, was 0.132 grams of aspirin. So what we want to do is compare our actual yield to what's called the theoretical yield. So the theoretical yield is how much aspirin we would have produced if everything went 100% correctly. We didn't spill anything, the reaction happened perfectly, which we know does not actually happen when we're in lab. Unfortunately, things go wrong. Maybe we spill some of the reactant or the product. Maybe some of it gets lost somewhere during the reaction. As we're transferring things, it can get stuck to glassware, etc. And sometimes there's contamination too. So what we want to do is figure out, okay, if we start with 0.25 grams of salicylic acid, how much aspirin would form if everything went well? So that would be our theoretical yield. So how do we calculate that? Well, remember to go from grams to grams, so grams of reactant to grams of product, we first have to go through moles. So what we're going to do first in step 1 is we're going to convert grams of salicylic acid to moles of salicylic acid. Now, do you remember how to go from mass to moles? What do we need to do that? We need the molar mass. So in particular, we need the molar mass of salicylic acid. Luckily, your lab manual already has that listed towards the end under the calculations and report section. So we're told that the molar mass of salicylic acid is 138 grams per mole. All right, so once we have moles of salicylic acid, then we're going to convert that to moles of aspirin. Now, what do we need in order to do this conversion? We need to figure out the molar ratio of salicylic acid to aspirin from the equation that we saw before. So if we go back to that equation, we can see that 1 mole of salicylic acid should produce 1 mole of aspirin. So the ratio will be 1 to 1. Super easy. Okay, so once we have the moles of aspirin, we're finally going to convert that into grams of aspirin or mass of aspirin. And similar to before, we're going to need the molar mass of aspirin. Oh, and then this is step 2, sorry. And this is step 3. So luckily, we're also told the molar mass of aspirin. So we're told that the molar mass of aspirin is 180 grams per mole. Okay, so let's actually perform each of these steps. So I'm just going to erase and make some room here. So hopefully you wrote all that down, but you can always rewind the video. All right, so step 1, we have our initial mass of salicylic acid. And then we're going to use the molar mass of salicylic acid to give us the moles of salicylic acid. So we were told that the molar mass is 138 grams per mole. Now remember, when we're using conversion factors, we want to cancel units to give us what we want. So what would go in the denominator? What do we need to cancel? Grams. So we're going to put 138 grams of salicylic acid in the denominator, and then we'll put 1 mole of salicylic acid in the numerator. Oops, sorry. It's zooming in on me. Okay, so see if you can figure out how many moles of salicylic acid we would have initially. So feel free to grab your calculator, pause the video, and then when you come back, we'll check the answer together. Okay, so for this calculation, I got 0.0018 moles of salicylic acid. Okay, so now in step 2, we're going to take that 0.0018 moles of salicylic acid, and we want to convert that to moles of aspirin. Now remember, there was a 1-to-1 ratio between salicylic acid and aspirin. So should we put moles of aspirin in the numerator or the denominator of our conversion factor? The numerator, because that's what we want to end up with, right? So 1 mole of aspirin. And then in the denominator, we put what we want to cancel. So that would be 1 mole of salicylic acid. All right, so 0.0018 times 1 over 1 gives us 0.0018. So you might have already figured this out, and that's okay. But if it's been a while, you can keep following along. Now, also feel free to cross things out as you go. So for instance, in the first calculation, we canceled grams of salicylic acid. In the second calculation, we canceled moles of salicylic acid. So now we're in the last step, and we need to convert moles of aspirin to grams of aspirin to get the theoretical yield of aspirin. So remember, we said the molar mass of aspirin was 180 grams per mole. So what would we put in the numerator? Grams of aspirin. And we'll put 1 mole of aspirin in the denominator because that's what we want to cancel. So we're just going to multiply 0.0018 by 180. So feel free to pause the video, do this calculation real quick, and then you can unpause and check your answer. Okay, so I got 0.324 grams of aspirin. So that's what we would expect to form if everything went 100% correctly. Now, we're going to compare that to what we actually formed in experiment, 0.132 grams. So we definitely didn't form the full amount that we could have formed. But again, that's totally normal in lab because mistakes happen, things get lost or spilled, or things get left behind in glassware. All right, so let's finally calculate the percent yield. So our actual yield was 0.132 grams of aspirin. And then we said theoretically we could have formed 0.324 grams of aspirin. And then we're just going to multiply that by 100 to get our percent. So feel free to pause the video and try this calculation first, then unpause and check your answer. So I got 40.7% as the percent yield. That's actually not that bad for a chemistry experiment. Many chemists are happy with a really small percentage of product as long as they get some product. But that's also a challenge that chemists have to overcome, is coming up with an efficient reaction that also produces a high yield of the product, because sometimes reactions just don't produce that much. Now, in your lab assignment, you'll be given different numbers because we're not going to start with exactly 0.25 grams of salicylic acid. We might start with a different amount. But at least now you have the tools that you need to do this same calculation and figure out the percent yield for the actual reaction we're performing in the lab video. Now, if you do have any questions about this calculation or the lab, feel free to message me on Canvas or by email or in the discussion board.